Hello everyone. So today we are going to continue the integration NCERT exercise 7.2 question number 11 to 24. So we'll start from the 11. The question number 11 we have given here, integrate cos to the power 4 into 2x. How we can integrate it? First of all, we have to reduce the power. So we are going to rewrite this integration. So integration of cos to the power 4, can we write it as cos square 2x? Yes, and whole square. The same thing we can write in the different ways. Why? Because now we can apply the formula of the cos square 2x here. How? So the formula, first of all, here we will note down the formula for the cos square theta is cos square theta, since here is equal to, we know that we have 1 plus cos 2 theta divided by 2. This formula we know from the trigonometry. So according to this formula, this I will become now I is equal to, we can say, integrate, here in place of the cos 2x we can write, it will become 1 plus cos angle will become 2 times, means it will become 4x divided by 2, right? And here whole square into dx. Now the constant 1 by 2 we can write outside, 1 by 2 whole square is 1 by 4, and here now we have just 1 plus 4x whole square. So we can apply the identities. So according to that identity, it will become 1 square 1 and cos square 4x plus 2ab, that means 2 cos 4x, 2 cos 4x bracket close into dx, right? Now here we have the two terms, directly we can get the integration of these two, but this middle term cos square 4x, again we need to apply the formula, the same formula what we applied in the previous, but here angle is different. So we will rewrite this as 1 by 4 integrations of here, in one bracket I will write 1 and 2 cos 4x. We don't need to do anything, so this will be as it is. But in place of the cos square 4x, here 1 by 4 I am writing separately. For this integration of cos square 4x, we can write as 1 plus, it will become cos 8x, cos 8, it is cos 8x divided by 2, here bracket close actually, and then dx. Now we can write our answer. So it will become 1 by 4 as it is. Integration of 1 is x and 2 is a constant, so 2 will be as it is, and cos integration is sine, so it will be sine 4x divided by 4, right? Now this is the answer for the first part. Now here 1 by 4 outside and integration of, and this 1 by 2 also we can take the outside, so here 1 by 2 will come as a, here in multiplication, so 2 into 4, right? Now here 1 integration will become x and the cos integrations will become sine, so it is sine 8x divided by 8, and then here plus c at last, right? Now we can just simplify it. What we can do here, how many x is there? Here we have 1 by 4x, and from here we have 1 by 8x. So if we add this, it will become 3x by 8. By adding these two terms here, this part and this part, we are getting 3x by 4. And now this sine 4x, so sine 4x, 2 and 2, it will get cancelled in 2 times, means sine 4x by 2 into sine 4x, here it is 2 into 4, it will become 8, and here we have 8x and into 8, 64, means sine 8x divided by 64, and at last plus c as it is. So this is the answer of the question number 11. Now we will move to the question number 12. The question number 12 we have, it is I is equal to, we have given integration of sine square 2x, just sine x, sine square x divided by 1 plus cos x. What we can do here? So first we can apply the formula for the numerator and denominator, both the things. How? So I equal to, or first we know that sine square theta is equal to 1 minus, or another formula also we can apply the 2 sine square x by 2 cos square x by 2, and from there also, okay, so instead of this we can, it will become cos 2 theta. So instead of this we can apply another formula, that is, first let me erase, sine 2 theta equal to, we know that what, since we know sine 2 theta is equal to 2 sine theta into cos theta, right? So we can replace the numerator sine x with this formula, and for the denominator we know that 1 plus cos 2 theta is equal to 2 cos square theta. Sorry. So here, according to this formula, this I will become, now I is equal to integrate, here we will apply the formula, it will become 2 sine x by 2, angle will become half, and then cos x by 2 bracket close, whole square will be as it is, right? Now this is divided by, what is the formula for 1 plus cos x? So 1 plus cos x will become 2 cos square, 1 plus cos x, that means 2 cos square x by 2, right? And here dx will be as it is. Now just open that bracket in the numerator part, so it will become 4, and here it will become sine square x by 2 cos square x by 2 into dx, and this is divided by 2 cos square x by 2. Now here, first of all, this 2 and 4 will get cancelled out in 2 times. This cos square and cos square also will get cancelled out. So we have just remaining here 2 constant outside. We can write sine square x by 2 into dx. Sine square x by 2 into dx. So that we don't have direct formula for the sine square, means again we need to apply the formula for the sine square x similarly. So like previous questions. So here it will become, what is the formula of sine square? It will become 1 minus cos x, 1 minus cos x by 2, and here dx. Which formula we have applied? So here, since we know that sine theta, or actually sine square theta, is equal to 1 minus cos 2 theta divided by, this is theta, divided by 2. So we are applying this formula here. Not directly we can write the answer. This 2 and this 2 will get cancelled out, and now we have just integration of 1 is, or 1 into dx is x, and cos x differentiation is integration is sin x. So it is sin x plus c. So final answer is I is equal to x minus sin x plus c. So this is the answer for the question number 12. Now we will move to the question number 13. What is question number 13? So here what we have given, question number 13 is I is equal to integration of cos 2x. This is very important questions, and minus cos 2 alpha divided by cos x minus cos alpha. How we can do that? Kindly everyone think what we can do here. So yes sir, we know the formula for the cos 2 theta. What is the formula for the cos 2 theta? So denominator part will not disturb. We will reduce this 2x multiple in the terms of the x. So since we know that cos 2 theta, or cos 2 theta is equal to 2 cos square theta minus 1, right? So we can replace both the cos 2x and 2 alpha. So our I will become, I is equal to integration of 2 cos square theta minus 1, and here minus as it is inside bracket we will write 2 cos square alpha minus 1, and this is divided by cos x minus cos alpha, and dx will be as it is. Now further if we simplify it, it will become 2 cos square alpha and 2 cos square alpha. It will get cancel out? No, it should, no, how it will, because angle part is different, it is theta and this is alpha, so we cannot cancel, so we will write as it is. But 1 and this 1 will get cancelled out, so we have just here 2 cos square alpha, sorry 2 cos square, here actually we have x, no, so in place of alpha we should write, here in place of theta we should write x, so this is x, so it will become 2 cos square x minus 2 cos square alpha, 2 cos square alpha, and divided by cos square, sorry cos x minus cos alpha. We can take the 2 common from the numerator, so if we are taking 2 common, here we have remaining cos square x minus cos square alpha, and this is divided by cos x minus cos alpha, and dx will be as it is everywhere, right? Now here we can see very clearly there is a identity a square minus b square. According to that we can write it as cos x minus cos alpha into cos x plus cos alpha, right? And denominator part will be as it is cos x minus cos alpha. Now we can see here which is the equal terms, so these equal terms will get cancelled out. Now we have just 2, and this is cos x plus cos alpha, cos x plus cos alpha, and here dx. Now we have to integrate both the terms, so 2 will be common, and here integration of the cos is sin x, and integration of the again cos alpha is sin alpha, cos alpha is a sin alpha, right? Sin alpha, sorry here we have done the mistake, sin alpha, or what should be the answer? Here it is not sin alpha, because cos alpha is a constant, right? Here this is a constant, so 1 second, here this part 2 will be constant, but here this is what happened, here we should write so it will become now what happened, here we can write the cos alpha will come as a constant, but integration of the dx will be x, and here plus c, so this is the answer, right? Now so here we'll pause.